What exactly is sound? It's not just noise. Sound is a vibration that travels through a medium like air, water, or solids. These vibrations create pressure waves that our ears interpret as sound. Without a medium, like in space, sound can't travel at all. That's why astronauts can't hear explosions in space movies. It's pure fiction. Sound needs particles to bump into each other to move forward. No particles, no sound. Simple, but mind-blowing, right? Sound travels at different speeds, depending on the medium. In air, it moves at about 343 meters per second. But in water, it's faster, around 1,480 meters per second. And in solids like steel, a whopping 5,960 meters per second. Why? Because particles in solids are packed tightly, allowing vibrations to transfer more efficiently. So next time you hear a train coming through the rails before you see it, now you know why. Ever notice how your voice sounds different underwater? That's because sound waves behave differently in water. Water is denser than air, so sound travels faster but loses clarity. High frequencies get absorbed quickly, leaving only the low, muffled tones. That's why whales use deep calls to communicate across oceans. Their low-frequency sounds can travel for hundreds of miles without fading. Nature figured out sound physics long before we did. Solids don't just transmit sound faster, they also carry it farther. That's why you can hear someone knocking on a wall from the other side. The tightly packed molecules in solids allow vibrations to move with less energy loss. But there's a catch. Solids can also reflect and distort sound depending on their shape and material. That's why concert halls use special panels to control how sound bounces around. So what happens when sound hits a boundary, like air meeting water? Part of the wave reflects and part transmits. This is why yelling underwater doesn't sound the same above the surface. The change in medium alters the wave's speed and direction, a phenomenon called refraction. Engineers use this principle in sonar and medical imaging. Sound isn't just noise, it's a tool, a signal, and a science that shapes how we interact with the world.